Cool. We are back. Forgive my voice. Should you hear my voice breaking? Nihoma. Nihoma si network. So forgive it. Itakuwa tu sawa. Itakuwa tu sawa. I'm under medication. So we started on networking yesterday, and today we did some amazing stuff in the morning where Joy took us through stuff that had to do with dealing with IP addressing, just understanding how those IP addressing are like. How do you come up with those particular IP addressing? How to break them down into bits and bytes, into zeros and ones. And you guys were doing some amazing stuff. And I saw most of you preferred the division method rather than the subtraction method. So team minus hawakukua leo, but you guys did some amazing job, and that was some good delivery by Joy. So this afternoon, we want to take it further, and we now want to bring you to the cloud. We want to bring you guys to the cloud. Give me a second. I open my supplementary notes on the side. Okay, good. So we want to bring you guys to the cloud, and now we want to start talking about services that are in the cloud that are related to networking. You know, networking is such a big topic, and it's such an important topic. And those who have been into IT and even those who have tried to do anything to do with, how do you call this? With trying to connect apps, trying to connect or rather deploy apps, you understand that sometimes you get errors because sometimes the site might be unreachable. You know, a site might be unreachable, or an app might be offline. And when you troubleshoot to figure out that the problem is actually has to do with how the network is working, how the various components of that network that supports that application are working. So, like any other topic that you've been doing, we will start by looking at the objectives. What are some of the objectives that we hope to meet by the end of this class? So by the end of this class, you should be able to explain networking in the cloud. You should be able to explain virtual networking in the cloud with AWS VPC. That's Amazon VPC, where VPC is virtual private cloud. And then you should be able to describe the key components of the virtual private cloud. And finally, objective number 4, you should be able to relate subnetting and classless interdomain routing, or CIDR, block addressing to Amazon VPC features. So you should be able to do that. You should be able to relate subnetting with CIDR block addressing and CIDR block addressing addressing to Amazon VPC features. Okay, so that is that. So we've already talked about the objectives, and now we need to go back to what we have covered. Remember what I've always told you guys, that when you are trying to understand something that is new, because VPC might be something that is new to you guys, one thing that you do, you try and use what you know to explain what you don't know, or rather what is familiar to you to explain that which is yet to be familiar to you. But rest assured that by the end of this topic, by the end of this whole module, networking, you'll be so comfortable even working with VPCs in the cloud, because VPC is like the mother of all networks, all networking in the cloud. Now, you can recall earlier that when you try to compare what we have in the cloud and what we have in the traditional network, I promised you guys that we will be mapping what we already know, what we've already talked about in terms of the traditional topology with what we have in the cloud represented by AWS service in this instance. So something like a data center. You guys, we talked about data centers where you get racks and racks and racks that have servers, that have network, that have cooling and stuff like that. So when you have that data center, the data center is what in the cloud you will liken to an Amazon VPC. You see, that data center gives you a network. It gives you a portion. It might be a big data center, but now inside there, you are given a portion where you can have your workloads hosted. So the same thing, you have it in the cloud. Yes, one, you have that main account that you've opened, your AWS account that you've opened. Then inside it, you can have a VPC or two. And we say that you can have a maximum of how many VPCs per region? Anyone that remembers? I talked about it. How many VPCs can you have per region? Kwenye walikuwa class. Yes, thank you, Abby. Thank you, Sandra. Thank you, Musembi. Naona watu wameamka vizuri kabisa. That is awesome. That is awesome. Yes, you can have a maximum of 5 VPCs per region. And remember, there are so many regions. And yes, Musembi, that was my next question, but thank you for answering. Then you can have up to 200, you can have up to 200 subnets per VPC. You know, up to 200 subnets per VPC. So when now you try to think about this, imagine now you have these VPCs in the cloud, in your account. You have, like, let's say you are 2 or 3 VPCs. Fact that you can have up to 5 doesn't mean that you need to provision all the 5 unless you have use for them. But now, assuming that you have 2 or 3 of them, maybe you are a big organization, and now you've decided that you want to maybe have 2 or 3 VPCs. And each of these VPCs have subnets inside them. And remember what we said about subnets. We said that subnets are like a division. Like you've taken your whole VPC and then you have divided it into portions. And these portions can either be defined as public or private. So you have public subnets and private subnets. But let's continue first of all with this mapping, where now we are talking about router, and we say that router, what you see as router in the traditional topology is equivalent to the route tables that you'll find in the cloud. And we'll talk about route tables. Then what you see as switches in the traditional topology is what you find named as subnets. Subnets, the one that I was just talking about. Subnets, which you find now in the AWS cloud. And then what you call firewall in the traditional topology is what in the cloud can either be security groups or NACL, Network Access Control List. And as early as now, make it a point to understand the difference between security groups and network access control. Mohammed, please mute yourself. You will band. Thank you. So I was saying that the firewall you meet in the traditional topology is the same as security groups and network access control list that you will meet where you will meet in the cloud. And we will talk about them. You'll get to see what they do and how they are different, how they differ from each other. So that is very important. And I'm telling you from as early as now, make it a goal that you will understand what security groups do and what NACLs do, or network ACLs do. That's one. And you'll also make it a point to understand the difference between what a public subnet can do or the features of a public subnet and a private subnet. I'm telling you that because those are actually examinable questions. Those are things that you will meet in your exams. So make it a point of understanding that very, very well. Ask us as many questions as you will want so that you understand it better. Then again, in the traditional topology, we have something that we call server and operating system. And then in the AWS service, something that equates to this is the AWS EC2. Remember, we talked about Elastic Compute Cloud, and we've been using Elastic Compute Cloud from the time we started doing our labs. So this is what is equivalent to what you will find in our online environment as server and operating system. And for the operating system, remember when you were provisioning the EC2s, you are choosing the operating systems in terms of the Amazon Machine Image, AMI, and we've been using Amazon Linux 2 as our preferred operating system, or rather our AMI. And moving forward, you will continue to see the others. Like today, today when I'll be doing the demo, I'll show you the other operating systems that are available so that you get familiar with them and you get to know that maybe in the future when you are doing either your side project or you are working for an organization, and then they tell you maybe we want you to provision using maybe using Ubuntu. There is an Ubuntu AMI, or Windows. There's also a Windows AMI. So all of these are there, and you will see them. So, but for now, for our labs, we are defaulting to Amazon Linux 2 because that is what has been advised in the labs. Then the modem that you will use, and you know what a modem does, it helps you to connect to the internet. So in the AWS ecosystem, what we have that maps to this modem is what we call the internet gateway. So internet gateway is the equivalent of a modem that you will find in a traditional topology. So we say that a data center is a data center as a whole most closely resembles the function of a VPC, because in a VPC, you can launch multiple AWS services that are needed to create a working and scalable network. However, within a VPC, no maintenance is required. You can create an isolated architecture within minutes, and you'll see that. And when you talk about you can create this, this isolated architecture, later on in the course, we'll be talking about infrastructure as code. And infrastructure as code, it means instead of you doing what you are currently doing, and what you are currently doing when you're creating this infrastructure is called ClickOps. ClickOps, click. Click, tack, 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 the way we click using a mouse. Click this, create this using ClickOps. That is ClickOps. Later on, when we'll be doing IaaC, IaaC is infrastructure as code. We will be provisioning infrastructure declaratively using what we call infrastructure as code tools. And there are two main ones. One of them is AWS specific and it's called CloudFormation. And then another one is cloud agnostic, meaning that it can be used across any other cloud, and it's called Terraform. So those are some of the things that we'll be talking about when we'll get to that topic. But just know that the same way we are provisioning this infrastructure right now using ClickOps, we can also do it declaratively using IaaC tools. And you will learn of the benefit of doing it using that when we come to that. But I just had to mention that in passing. Then we say that a data center involves multiple components. So in a data center, you'll have the like of internet, server, firewall, switches, and more. And like a data center, a VPC requires the same services to operate. So a VPC requires access to the internet, a VPC requires firewall of some sort, a VPC requires some servers inside there, and a VPC also requires some switches, which are presented in terms of subnets, as we saw in that table above. Then a router in a traditional environment has multiple functions. We say a router in a traditional environment has multiple functions. And some of these functions include filtering packets, routing traffic, and storing them in a route table. Now, when you come to AWS, the services that most closely resemble a router is what we call a route table. And you'll see what a route table looks like when we get to the demo, where the owner inputs routes within the VPC. The owner inputs routes within the VPC. You know what routes do? Like, let's say, for example, I want to leave this place and go to town. I can go through different routes, you know? Okay, let me just give this example. I live in a place called Kawaida. I want to get to town. I can either go through Limuru Road or I can go through Kiambu Road. You know, I can choose either of those. So I can choose if I want to go through Limuru Road or I want to go through Kiambu Road, Kiambu Road. And sometimes, strictly speaking about route tables, when you have when you write your rules inside the route table, it will define the path to which your packets or your data will flow. And that data will only flow through that route that has been defined, you know, through that route that has been defined, and it will not follow any other. So if I was data, and then there is a rule that has been written that I can only go to town through Kiambu Road, then I cannot use Limuru Road, in as much as that one also can take me to town. You know, so we are using these analogies just to help you guys understand. So that's what a route table does. You know, that's what a route table does. So we say that in AWS, the service that most closely resembles a router is a route table, where the owner inputs routes within the VPC. Then we move on and talk about a switch. And say a switch acts as a subnet and it switches data as it comes in. Now, AWS uses subnets in every architecture. Any architecture that you will come across, and architecture, we mean that, okay, architecture can be represented as a diagram where you get to see how different services are arranged, or how they relate to each other, or how they connect to each other. So you can see a VPC, you can see subnets inside them. Inside the subnets, you can see maybe in the public subnet, we have an EC2 instance. Then you can also see in the private subnet, maybe you have a database server. And then maybe we have all of this in availability zone 1. Then we have another availability zone. Then in the second availability zone, in between them, maybe we have a load balancer, which defines where will traffic move, maybe in the instances, stuff like that. Then in these two availability zones, you can see maybe replication of data. Maybe we have a main database in availability zone 1, and then we have another database in availability zone 2. Now data is able to be replicated in near real time, so that it makes sure that in case availability zone 1 goes down, availability zone 2 can pick up. You see, that is designing for high availability. You are designing for high availability just to make sure that in case the first one drops, the other one can pick. And you can also say this is also designing for fault tolerance, such that if one fails, the other one can always pick up and do the job. All these things that I'm talking about, mentioning them in passing, yeah, they are things that you will cover in this very module that we are doing, networking. So when we say that every node that is EC2 belongs in a subnet, we mean that an EC2 instance does not you don't just put your EC2 instance anywhere. I know you guys, when you were creating EC2 instances, we were using the default setups that have been given to us by the lab environment. You understand? And I told you, anytime, the moment you create an AWS account, you will automatically be given a default VPC. And VPC has components, and some of those components include subnets. So when you are creating your EC2 instance, you'll discover that inside that this EC2 instance is normally placed inside a subnet. And if you are keen when you are creating your own instances, you must have seen that when you try to create an instance, you are always asked a question. You're given two choices. When you are creating this instance, do you want this instance to reside in a subnet that has already been created? And this subnet that has already been created, it has been created in relation to the default VPC. You see, because it is a component of the VPC. So you are bringing your EC2 instance, you put it inside a subnet. So that's what we mean by saying that every EC2 instance belongs in a subnet. And although the functions of a switch and an AWS subnet does not match as in to 1:1. You cannot map them directly. The function of a subnet for both the functions of a subnet from both work the same architecturally, because you will come to discover later when you get into talking about subnet and even doing the demo, you will come to discover that subnets also work in terms of they also filter. They can also have rules that determine, can this EC2 that is inside this subnet, can it communicate to the internet, or can it communicate to other instances or to other resources? Can it or can it not? So all that can be done there. So subnets are used to logically isolate groups of internet protocols together. So they are used to logically isolate groups of internet protocols together. So any place you see internet protocol, just remember IP, the same IP that Joy introduced to us this morning. So let's talk about these firewalls that we've been talking about. Now, firewalls, they serve to block traffic based on set of rules. So there are rules that you will set and say, by the way, traffic from this should be allowed, traffic from this should not be allowed, or traffic to this should be allowed or should be disallowed. AWS has security groups. There are these things we call security groups that block traffic at the node. At the node, we mean at the EC2 level. So security groups block traffic at the EC2 level, and network access control lists, or what I call knuckles, block traffic at the subnet level. You see, we've already started seeing the difference between the two. We are told that security groups block traffic at the EC2 level, and network access control list block traffic at the subnet level. And remember, subnets are, EC2 instances are inside the subnet. So if you think of your subnet as, let's say, a house, inside it, there is a room. So that small room inside that main house, that main house. So the main house is what you call your subnet. The room inside it is what you call an EC2 instance. We will find better illustrations as we continue. But just get that one in your mind as you move. These security groups also block traffic. They also block traffic based on a set of rules. And these rules, just to mention again in passing, these rules are what you will find when we will be doing the demo. We call them inbound and outbound rules. Inbound and outbound rules. As the name suggests, inbound, coming in, outbound, going out. You see, so just understand it that way. Then a data center has servers and operating system. So in AWS, you can use an EC2 instance to launch an array of servers or operating systems. The way I told you, we have different operating systems, and we'll get to see each of these operating systems in due course. So everything must be connected to the internet through an internet service provider, ISP. One that you might be familiar with is called a modem. So we have been using modems. And modems is what allows us to connect to the internet, where an ISP provides internet to your home. So yesterday when I was explaining networking components, I talked about those who have, let's say you have Wi-Fi installed in your house. So what those guys did, there is normally a white box pale chini that receives connection, a wired connection from, like in my case, let me give you the setup of my place. They came and then wakaingiza wire from the pole, they passed it through a window, and then from that window, it went all the way to my living room. So kuenda hivyo ikateremshwa chini, then they placed a box. They placed a white box. So the cable came into that white box. From that white box, there is a wire that now goes to my router. You know, now this white box, yes. So now this white box is what simulates what we call a modem. And then that we have a router up there. So that router has, that router also acts, okay, I normally say it acts also as a switch because it also has those ports. If I was interested in connecting anything using an Ethernet cable, I will do it because it has those ports, you know, but it is, okay, the location where it is, it's a bit difficult for me to use those ports anyway. So I use Wi-Fi across all my gadgets. You know, across all my gadgets, be it my TV, be it my laptop, be it the phones in the house. When my friends visit, when they want access, they all get from that. So that is like how it looks like. And you know, now we are talking about a modem that gives you access. That is in the physical topology. But now in the cloud, a VPC on AWS and the services also have to get internet. They also need access to the internet. You know, they also need access to the internet. And this is achieved only through what we call an internet gateway, IGW. Start familiarizing with that is it acronym or short form? IGW represents Internet Gateway, and we'll talk more about it. So on a high level, that was just an introduction of trying to map what we are already familiar with through this course, through us introducing you to networking, what you're already familiar with. Now we are trying to tell you whatever we've been talking about in terms of on-prem environment. In the cloud, you will meet them and they will look like this. They will look like this. So we hope that as we continue, you guys will continue to even deepen your understanding. So let us look at VPC. And I remember we talked about VPC when we were doing our intros back, I think it's in week 1 or week 2, and we just did a high level, or was it this week? We did a high level introduction of VPC. And here we are going to do the same. And we will say here that a VPC is a service that you can use to provision a logically isolated section of the AWS cloud. Remember those words, logically isolated section of the AWS cloud. That is very, very important. So you can use it to provision a logically isolated section of the AWS cloud. So utapata mahali, maybe a question in your exam, or even a question in the KC, or a question in your practice test where you are asked, define a VPC. And then there is that choice that has that answer, that a VPC is a logically isolated section of the AWS cloud. Very important. So this service is called a virtual private cloud, or Amazon VPC. And with Amazon VPC, you can launch your AWS resources in a virtual network that you define. So it is you to define the network. You've been given that power to define the network. And we will see in the subsequent slides how to define this network. So what does it do? Amazon VPC, what does it do? So let me check something. 38. Okay, so the numbers are increasing. That's encouraging. So for those who came late, please next time try and come to class early. And if you found me continuing and you're floating, I'm sorry, but we've agenda sana, so you can always go back to the recordings. The recordings will be with you by end of day. So we are asking, What does VPC do? What does Amazon VPC do? So number one, it gives you control over your virtual networking resources. It gives you control over your virtual networking resources, including you are able to select an IP address range. You are able to create subnets. You are able to configure out tables and network gateways. And it also gives you the ability to customize its network configuration, the configuration of your VPC, and it also gives you the ability to use multiple layers for security. So when you're talking about these multiple layers for security, of course, even before you hit the VPC, there is normally a service like what we call WAF. WAF is, what is WAF in full? What is WAF in full? Let me check. AWS WAF. It's a firewall. It's a firewall that is web application firewall. Yes. Web application firewall. So you are likely to meet a web application firewall, which is like the first line of defense. Then you get to the VPC. When you get to the VPC and start getting into the likes of maybe you'll get the WAF is already associated with the internet gateway. So you have like the first level of security there. Then the second level of security, you meet it at the subnet level. Where, what did we say about subnets? Subnet, you'll get a level of security that protects you there in terms of network access control lists, which it only allows some form of traffic in. Then once you are in and now you are moving towards the instances, then what else will you get there? When you get into an instance in a private, in a public subnet, you will get that it has what it is associated with security groups. Security groups also gives another layer of security. And aside from that, if you have your workloads, let's say you have another instance in the private subnets also have that additional layer of security, which what does it do? Which ensures that internet traffic from the internet does not get to the instance. It does not get to the instance. And you'll see that when you'll be talking about it. So this multiple layer of security is very, very important. It's very, very important. So I will leave these speaker notes for you to read because they are actually the same things that I've explained. And now we ask ourselves this question here. Why use an Amazon VPC? And the short answer is presented in these points that you see. Like the first one, you can spin up a logical environment of what was previously in a data center within minutes in the cloud. You see, the same physical environment that you had in your data center. If you decide to migrate your workloads to the cloud, you can simulate it, or rather you can spin it in the cloud in a matter of minutes. Whereas in the data center, let's say, for example, one of the things that has forced you to migrate is the fact that you discover that your workloads are expanding, but they are expanding faster, or your demand is growing faster than what your data center can hold. So you are weighing between buying extra servers to make sure that you keep up with the demand, or just moving everything to the cloud. And then maybe a cloud architect like Musembi visits your data center and then advises you using the TOC. TOC. Was it TOC or TCO? I think it's TCO. TCO. Total something of ownership. Total cost of TCO, total cost of ownership. Yani total cost of ownership, you do the maths, and then you say that if you are to continue running this data center, it will cost you this much. However, if you shift it to the cloud, this is the math that you're going to incur in terms of spend. And for most businesses, what they always want to see, or what they always strive for, is to make sure that their cost of operation is as low as possible. Because remember, if the cost of operation is high, they can only shift up to a certain limit to the customers. Yani the cost, they can only shift up to a certain limit. So it means that it means that they have two options. If they want to maintain their margins, is either they increase the prices for the services that they are offering, which might work against them, and customers might decide to abandon them for a competition that is offering the same services at a cheaper price, So it's very, very important for you, working either as a cloud engineer or a solutions architect. When you're talking to a client, you're supposed to make them see the sense. And there is nothing that makes people see sense more than showing them, even organizations showing them that this is the much that you stand to save. You know, this is the much that you stand to save. Yes, Musembi, that is very right. Even the ROI, even the ROI is very, very important. You need to show this because this is what makes sense to organizations. You know, so I've told you that it is very possible for you to spin these things in a matter of minutes in the cloud and even tear them down if you don't need them anymore. You know, tear them down if they don't need them anymore. Compare that with you having increased the number of servers. Maybe you are increasing the number of servers in your physical data center because there is this big contract that you won. There's this big contract that you've won that maybe client XYZ wants to procure your services, and you estimate that you'll need like 5 more servers. So you go for these 5 more servers, and then something happens. This client tells you, oh, now you know, this thing has happened. This thing has happened. Now we are not able to honor that. We're not able to continue with you. So you either go sell these things for black market, or just maintain them with the hope that you'll get other clients, but you'll be incurring spend for them. And there's also something that we call CapEx. And I think we talked about it, capital expenditure, where you are now buying these servers, but in the cloud we are renting. I hope that one is still making sense. And I'm repeating these things just to make sure that these things stick with you. Now, we also say that it is more cost effective than maintaining equipment in a company data center. You pay for only the resources that you use. That's what I've just explained. And then it is designed so that companies can migrate and use AWS cloud services easily. I've also explained that it is secure, scalable, and reliable. Secure, scalable, and reliable. That one, think about the shared responsibility model, where AWS is responsible for security. Where? Somebody tell me, what is AWS responsible for? And what are you as the customer responsible for? Nataka kuona wenye alishika that unit. What is AWS responsible for? And what are you responsible for?
AWS is responsible for security for the cloud, and the customer is responsible for security in the cloud.
Very nice, very nice. Always remember that. Always remember that. Thank you, Clinton, and thank you everybody that's engaging with us on the chat. So always remember that AWS is responsible for security of the cloud, and you as a customer is responsible for the security, in the cloud, of the cloud, AWS, in the cloud, you. And always remember that, because a shared responsibility model, if memory serves, if I remember well, I think we had like 2 or 3 questions during my time when I was doing my certification exams. We had 2 or 3 questions that came in different flavors with different twists. You know, so Ivaio, make sure that you are very good with that. Make sure that you are very good with that. Then we also say that it works with many innovative AWS and third-party services. So the VPC works with many innovative AWS and third-party services, and you'll get to see those when we continue with this. And then you can create multiple VPCs and create test environments before they go live. Yes, you can create multiple VPCs and create test environments before they go live. And now, again, leaning on an experience I had working with an Amazon partner network here in the country, one of the things that we used to do, there is this thing that we do called POC, proof of concept. So a customer that wants to migrate their workloads to the cloud, what they will do, they will approach you. They will approach you as an Amazon partner network, and then talk to you and ask you and actually talk to you about their requirements, or communicate their pain points to you, or communicate their concern, why they feel that now they really want to move to the cloud. Apart from giving them the TCO is good. TCO is good. But apart from giving them the TCO, you will also need to do a test run of sorts. This test run is what we call the POC, proof of concept. So proof of concept, let's say, for example, like there is this customer, I remember I was leading a project where we were doing file server migration. So initially they were storing their files on-prem. Now they needed a server in the cloud where files that have been worked on or are being worked on can now be replicated in the cloud. Because they discovered that their physical file server was getting it was getting, English is difficult, filled up. Is that the right English? The space in the file server was getting lunch nimekula nini? I've eaten no English. Let me see. So I hope you guys are getting, as their file server was getting filled up. So they needed a solution which would ensure depleted. What your English? Hey, Leonard. Yeah. That word is big. Thank you so much for that. It was getting depleted. Their space in their file server, in the physical, was getting depleted. So they wanted a solution which will do two things for them. They wanted something that will cover them in case of a disaster, and they also wanted one that they can also be transferring their files to the cloud. And for them, it was not even about not even about consistency. Okay, they did not really want. They did not have strict demands that whatever they have in the cloud should be the same as what they have on-prem, as in match every minute. No, they had like an allowance of 24 hours, or no, actually it was 12 hours. Within 12 hours, whatever they have worked on today could now be transferred to the cloud. So, if you have a file here and then it is mapped in the cloud with the same name, it means that if I work on it and I save it here, later on when syncing, is it called syncing or syncing? When syncing is happening, what will happen is all the updates that I've done in the copy that I have here will now be copied to the cloud. And just in case there is any problem in terms of maybe I lose the copy that I have here, I can always get a copy from the cloud. I hope that one makes sense. So when you do that, you are trying to make sure that you enjoy the security, the scalability, and the reliability of the cloud. So that one makes it very, very possible. And again, you will get into an organization which maybe they are working on an application, like there's a health tech that I was engaged in. Then when you work when you're working in an application for devs, you understand when you're working with an application, it is safe to have like 3 environments. It's safe to have like 3 environments. Any dev in the house, can you tell us what those 3 environments are? What are those 3 environments that within the SDLC, software development lifecycle, you need to have like 3 environments so that your final product that now reaches the end user is now a complete and a properly tested and working application. Yes, those are the 3 environments to Anthony. Thank you for that. So we have the developing or the dev environment, the staging environment, and the production environment. So you can provision this. You can actually provision like 3 VPCs and name them the same. You have a dev VPC, a stage VPC, and a prod VPC. You see, woe unto you if you take something that is full of bugs and just push it straight to production without it having gone through the entire cycle and even gone through the test that it needs to go through. So it's very, very important for you to do that. So the VPC gives you that, that flexibility. And again, you're welcome to read through these speaker notes because they are the same things. And now we are now going to the cool stuff, where we now want to start talking about VPC features. Sorry. VPC features. Let me try and open something on this side and see. Is it Lucid Charts or what? Was I using, there's Lucid Charts and then there is Draw.io. Draw.io. Give it a second. It's something that I'm opening in my secondary monitor. Once it is ready, I will show you. I think it's ready. So I want you guys to tell me that you can see what I have shared on my screen. Are you seeing something like a diagram of sorts? Are you seeing a diagram of sorts?
Yes.
Yeah, cool. Now, again, I'm just going to mention this still in passing because that is how I like teaching. I mention it in passing so that when you mention it again another time, it will now have stuck. It will now give you a reintroduction to what you're already familiar with. If you've never seen a diagram like this before, this is what we call an architecture diagram, a cloud architecture diagram. This is how it looks like. Remember, you see a role like a cloud, cloud solutions architect. You hear that name, architect. If you want to build a house, you don't just wake up and go and start building a house. No, you need to sit down with someone who will put your ideas in paper. If you're not that skilled, if that is not your strength, you will need to visit an architect who will take your ideas and put it into paper and tell you, for example, you want a five bedroomed house. So you want it maybe as a bungalow or a maisonette. I hope that's the word. So this is what you want. These are some of the designs that I have for you. So similarly, when you are trying to onboard a client into the cloud, or even when you are doing your on-site projects, it is always best practice to start with an architecture diagram. Once you have your ideas in your mind, you can put them down in paper or in a drawing in terms of an architecture diagram. So what an architecture diagram does, it gives you a visual representation of what you have in your mind or what you have in your problem statement. As in, I want this, I want this, I want this. Like, I want to have like 3 instances. I want them to be in these availability zones. I want them to be in this region. I want it to be connected to this security service. I want it to be connected to this database. I want it to be connected to this other thing. All that's what we call an architecture diagram. And this, you will get familiar with this by the end of our course. You will get familiar with this, but now you will even get a better understanding of it when you do the next certification, which by default, for most people who want to go deeper in cloud, is normally solutions architecting. So for solutions architect, such as myself and Joy, this is some of the things that we normally do. These are some of the things that we do for work. We draw these architecture diagrams for clients, and also we do them for our own side projects. So you will get to see this. And then what I wanted to draw your attention to is that we have specific icons that represent specific services. Specific icons that represent specific services. Let me make this one a bit bigger again so that you can see. You can see here we have the AWS cloud. The AWS cloud, and everything here is inside the AWS cloud. Now, in this diagram, we don't have the VPC. It has not been shown, but we normally have a VPC, and you'll see it in the slides. You'll have a VPC, you'll have the subnets, you'll have the availability zones, you'll have your instances, all that. So you can have the whole of this. Doesn't it look cool? Sinakapo. You feel like drawing it? You feel like drawing it? I can see you, Musembi. I can see you. And Kiprono, you are really eager to start drawing these things. And that is very good. That's very good. That kind of eagerness is very, very good. And you guys will be doing this very soon. So I wanted to show you that. So we have like a number of tools that you can use to do this. One of them is called Draw.io. So Draw.io, you can use Draw.io to draw this, Draw.io. And then there's also another tool called Lucid Charts. So I've used those two in collab with others. There are also other tools, but these are like the 2 main ones that I've used. So I just wanted to introduce you to that. Now, what you've seen there, I've shown you how the AWS cloud looks like. So it looks something like this. Let me see again, just a second. Can't I start without I was hoping that I can start without creating an account. Don't want to waste time there. Give me a sec. Yeah, let me use this one. Let me use this. There is something I want to show you, which I gather it's important. Okay. So this is like your working canvas where you're going to draw your things. A canvas is just similar to what someone that is designing anything will do. So if I look for something like AWS, for example, if I look for AWS, give it a second, more results. I'm not seeing what I want. 1 second. So I can use AWS 2025. This AWS 2025. Okay, good. Apply. So if I come back here and say AWS, what else are we getting? not that, not that. I wish I was using my other computer. It would have been easier to get them because I've been using them over and over. Let's see what we have here. Calculate. Nope, 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 nope. No. Okay, let's use this one for now. However, this is not the best, but you can use it for now. So you have like your AWS. This is your account. Then inside it, you want to have a VPC. You want to have a VPC or VPC, for example. Sasa ndio zimeanza kukuja the colors that I want. You can have your VPC inside your AWS account. Let's say that we are only going to use one VPC, although you can have multiple VPCs, or let me just have like 2 VPCs. This is just an illustration. I'm not going to go deeper. Okay, so then here, Control CV. So we have like these 2 VPCs. So you have this, and then now this is inside your AWS account. You now have your VPCs. Then inside these VPCs, let's say, for example, you want to have subnets. Subnet, you see that is a subnet. You can come and say, for example, you want to have a subnet here. Then you want to have another subnet here. Let me just have 2 subnets, although you can have like 4. But let me just have 2 subnets. And then of course, remember that you can always edit these things. So I can call this one public subnet, and I'll be explaining these things. So worry less. Then we have private subnet. You see that? And then CV. Let's see if we can replicate it this side. We have that CV. Then you have that. So we have 2 subnets in these 2 VPCs. And then if you want these 2 VPCs maybe to communicate with each other. Oh, sorry, not that. Control Z. Take this one here. On my drama, Control Z. Control Z. Good. Don't do that. Why are you going down? Control Z. Let me move it up kidogo. Hi. You are hell-bent on just going down, eh? No worries, no worries. Leave it. Where has it gone? Imeenda huko nje, no problem. So let me pick a different one. Control. Yeah, we can control it. Yeah, so you see that's now like a peering connection. You understand? That is like a peering connection where now VPC1 and VPC2 is able to talk to each other. And the way we told you that it is actually possible for 2 VPCs to talk to each other. And these things we'll be talking about them. So I just wanted to show you that there are specific icons that you can use. And even for our EC2, for example, I think I will end it with the EC2. I'll not go more than this because this is still early in the class. It's a specific one that I'm looking for. EC2. Yeah, that one is what I was looking for. So what we are used to using, Control CV. So you have an instance there, CV. You have an instance here, CV. You have an instance here, and then you have another instance here. And now, because this is your VPC, this is your VPC, and you want to give them access to the internet, you give them access to the internet by giving them the internet gateway. Internet gateway. It's a very nice icon. This is the icon for the internet gateway. And because we have 2 VPCs, I'm going to use 2 representations. We have that. CV. We also have that. So our by you. Oh, sorry. Sorry for that. So by you doing what? By you having by you having the, yeah, Frank, I know it's cool, eh? It's cool. It's always good to show you guys where you guys are headed so that mtavumilia. Sorry, Frank. So that you guys can endure even the pace in which the course is proceeding. But these are like things that you guys will be able to do with a lot of ease. So this is the internet gateway. You know, this is the internet gateway that we keep talking about. This is the internet gateway. Now, the internet gateway gives your VPC access to the internet. You know, it gives your VPC access to the internet. And remember, it is not that everything. Unaona? You know, ati hii sasa ndio inabamba Jo. Thank you, Mark. Thank you, Mark. So I need to get rid of this. This is not needed here. So equally, you can also just have it here, in between here, and then have two arrows from this to this side. There are different ways that you can represent it, but in most architectures that I have drawn myself, both for work and also for my personal projects, I've just been doing a single VPC, not two VPCs as you see in this diagram. But I just needed to draw that for you guys so that you guys at least can see and you can get to start to appreciate when you're talking about VPC components. This is what we mean. You have your AWS account, and then inside it, you have your VPCs. Inside the VPCs, you start meeting the likes of subnets, and then inside the subnets, you start now getting your instances. And then there are other things that will come in between that we'll be talking about as we proceed with the course. So that was a good breather. Now, remember, yes, I've shown you the VPC. The other things that I've not shown you. The other things that, yeah. Now, there are two questions in the chat. So, is a VPC same as a VLAN? Okay, let's see. Just a second. I'll answer your questions. We will answer your question. Let me look at that first question. Just get you an answer. You're asking if a VPC same as a VLAN. So VLAN, a place that I've used VLANs is when I was doing CCNA, and VLAN is short for virtual LAN, virtual LAN. So I'm not very sure if they map one-to-one. I'm not very sure if they map one-to-one. I think where they are similar is the fact that they are both virtual, but in terms of their functions, let me just I'm looking at the documentation for VPC, because that's a good question. And I think you've been asking me about VLANs several, or someone else has been asking about VLANs. Just a second. So what I'm getting is, no, a VPC is not the same as a VLAN. So VLAN is virtual local area network, but they serve a similar purpose in different contexts. So in terms of VPC, we've said that a VPC is a virtual network within our cloud providers infrastructure such as AWS, and it serves to logically isolate your cloud resources, you know, from other tenants. So, sorry. So from other tenants. And then VLAN is a logical segmentation of a physical network. You know, it's a logical segmentation of a physical network in a data center or on-prem environment, and it actually isolates traffic within a switch or set of switches. You see, so when you talk about switch in the cloud, it's the same as subnet. It is more or less the same thing. But you see now they are saying it is in terms of where they are found. One of them is within a cloud provider's infrastructure, when this other one is found in a data center. So mapping them one-to-one might be difficult, but yes, it is conceptually similar. It's conceptually similar. And I think their similarity, their similarity mostly is because they both create those isolated network segments. As you've seen, one of them will create the isolated network segment in the cloud, another one will create the isolated network segment on-prem. On-prem. So I will share with you, I'll share with you something that I have found. Just remind me, maybe after class, I'll share with you group, difference between VLAN and VPC. That is good. That's good engagement. Thank you, Dan. And thank you, or was it Silas for the question? Thank you. And then where does the route table fall? So we have said we are going to talk about the route table. So the route table is what defines, and you will see you'll see exactly where it falls in the entirety of that concept. I just skipped forward to show you the representation so that you have a mental picture as I'll be talking about them. When I talk about internet gateway, you'll have at least seen even how the thing connects to the VPC. So where should internet service provider come in, or is it in the internet gateway? So the internet service provider, you know, when you're connected to the internet, it will connect, all VPCs connect through the internet gateway. So if it is access to the internet, which is provided by the internet service provider in the on-prem environment, so that is what simulates to what the IGW does, the internet gateway. And I remember that table that we are talking about, we talked about how we can map these things, and we say that modem that is provided to you by the internet provider is the same as the internet gateway, or it maps to the internet gateway that you will find in the cloud. Yes, thank you. Awesome, cool. So that was good. Then we are talking about one, it is the VPC is found inside an AWS account, and then a VPC belongs to a single region. That's important. Remember that our VPC belongs in a single region. When we'll be creating our VPCs, you'll see we will have to state in which region we want it to be. And most times it will default to the region in which we are currently operating in. If Paleju, it reads US East 1, that is where the VPC will be created. And then we say that it can span multiple availability zones. You know, your VPC can span multiple availability zones, meaning that you can have availability zones, a couple of availability zones inside, okay, the VPC in its picture. Let me see if I can drag it back to explain that point. In its picture like this VPC, when you are drawing your availability zones, let me get rid of this so that I can draw the availability zone first. So when you're drawing your availability zone, so your availability zone looks something like this. You see, it is also a box. So if we take this as our availability zone, let's make it a bit smaller, like that, and then we extend it. You see, it spans. Kuspan namanisha, it is not confined within that availability zone. Within that region. It is not span inside that VPC. It's not span inside that VPC. Sorry, not region. Not region. Control CV. Another one. So again, in most of the architectures that I've done, I've been drawing them using like 2 availability zones. You know, I've been drawing them using like 2 availability zones. So you can have this availability zone and this availability zone. And then again, within this, you can now have your subnet and another subnet in 2 different availability zones, another subnet and another subnet. You see, now that one you're now designing for both fault tolerance and high availability. You know, because now your workloads are in different availability zones, such that you remember things happen. And recently you saw what happened, but what happened recently to US East 1, that one was regional. That was not availability zone specific. So you have something like this. You understand? You have something like that. So when you talk about that, this is what we mean when you talk about availability zone. So I will not belabor that. And then it is logically isolated from other VPCs. It is logically isolated from other VPCs. Again, back to our picture so that I show you that. You see, this VPC is separated from this other VPC. For you to make sure that they are able to communicate, you can now do what we call a peering connection, a VPC peering connection. That's what makes it possible for the 2 of them to communicate using AWS backbone infrastructure without traversing the internet, without going through the internet. So they communicate using AWS's own infrastructure, but now they don't, it doesn't go through the internet. Maybe you want the two to communicate. But now without this, without, oh, sorry, these diagrams. Oh, just a sec. Control Z. There goes, highlighted. Yeah, now without it, the two VPCs cannot communicate. That's what I wanted to show. The two VPCs cannot communicate. That's important. That's important. So those notes, they just explains that. Now, here is an example. Here is an example. And in this example, we are talking about a VPC that now we have multiple VPCs which can span different availability zones. So you have VPC 1, VPC 2. We have like 6 VPCs, you know. We have 6 VPCs. What did we say? What did we say about yeah, I'll get back to your question, Gideon. I'll get back to your question, Gideon. So what did we say about our VPCs? How many VPCs can you have in a region? How many VPCs can you have in a region? I started with this question and people answered very well. Why are you afraid? Mnajidoubt? 5. Yes, you can have 5 VPCs in a region. So this illustration in itself is not accurate because here we are being shown that these are 6 VPCs in a region. So this illustration itself is not accurate. But again, extend grace even to the guys that created this because things might have changed. Remember, we told you that some of this content was first released in 2020. So that's like 5 years ago, and no, technology keeps changing. So yeah, I get you, Tony. But now we're talking about, strictly speaking, it's supposed to be 5. So maybe our best description would be to show this at least with maybe 4. 4 would have served the purpose. But yes, you can actually increase that quota by talking to support. That's very important. Thank you for reminding us that, Tony. So Amazon VPC features offer the following benefits. So some of the benefits that are offered by the features that we've talked about is that 1, you can create multiple Amazon VPCs in your AWS account to separate networking environments. And we talked about the 3 primary environments for software development, where we have the dev, the test, and the dev, stage, and prod environment. And you can create subnets in a VPC. However, fewer subnets are normally recommended. Fact that you can have up to 200 subnets in a VPC, it's not recommended for you to do all of that. There is a number in which Ukshafika, once you hit that number, it is important for you to start considering maybe provisioning another VPC. And if you need the 2 VPCs to communicate, there's always peering for you. Because again, think of it this way, you're trying to connect multiple networks. You know, you're trying to connect multiple networks. It becomes complex. Remember when we were talking about those topologies, a mesh topology is messier than the likes of star, bus, star, ring topologies. So you are trying to make sure that the nodes that you are connecting in your network are not so many to an extent that they confuse you at the end of the day. You want to make sure that you have your network working seamlessly. So you are encouraged to try and have fewer networks. But again, we also say that it's important for you just to provision what is sufficient for you or your organization to work as it should. So I hope that makes sense. I hope that makes sense. Now, in the morning, you guys talked about IP. You talked about IP addressing. We had a very good introduction to IP addressing, and now we want to take this a bit deeper, and I'll talk about IP addressing in the Amazon VPC. I've told you that VPC is like the mother of networking in the cloud. It's like the mother of networking in the cloud. So how does IP addressing work in Amazon VPC? So when you create a VPC, you must specify IPv4 address range by choosing the CIDR block such as 10.0.0.0/16. You see that? 10.0.0.0/16. So an Amazon VPC address range could be as large as /16. Fun fact, if you see this slash, it tells you the number of addresses that CIDR range can accommodate. Then another fun fact, the smaller the slash, the more the number of addresses that it can accommodate. For instance, a /16 will have 65,536 addresses, while a /28, which is a bigger number, will have fewer addresses. That is 16 addresses. You get? So 16/16 will have 65,536 and /28 will have 16 addresses. Now, by default, and I've seen this both doing my own personal projects, doing group projects.
Pardon on that.
Oh, yes. Which one? The slash?
Yes.
Ah, good. Okay, so for the slash. Now I'm saying if you see a CIDR block represented with a slash, this slash here gives you an idea of how many addresses can be found in this range, in this CIDR range. How many addresses is accommodated here? And here you see it is /16. So /16 is large and it can accommodate up to 65,536 addresses. And then /28, which looks bigger than /16, has only but 16 addresses. Okay, hope that makes sense. Mpaka hapo tuko pamoja? Are we together up to that point?
Yes, tuko kimoja.
Awesome. Thank you. So it is important. Why are we talking about CIDR block ranges in a VPC? Remember, if I tell you that a VPC is the mother of networking, then it follows that the components that are inside that VPC, the components that are inside that VPC are supposed to be able to communicate with each other, because our VPC in itself is that logical network, and then inside it we have subnets, which are subnetworks. So these subnetworks are going to be part of what we are talking about. They are going to be part of this CIDR block range. They're going to be part of this CIDR block range. And Dan, you've asked a very important question. Why invite the numerical logic in the CIDR block? Personally beats me. I wish they did it the other way around, so that you just know small is for small, big is for big. But again, you know how scientists think, especially computer scientists. We like complicating simple things, or maybe they had another logic. I might be answering it simply, but maybe there is another logic. Let me take a pause here and ask something. Just a second. Sorry. Where is it? So I took that pause to check to go back to documentation for VPC, just to figure out an answer to a question that was asked earlier. Sorry, Gideon, for keeping you waiting. So according to documentation, it's actually possible to do peering between VPCs in different regions. It's possible, but now you'll use what we call inter-region VPC peering. You'll use inter-region VPC peering, something that is slightly above the content of this course. So should you reach a level like, let's say, you decide to do a developer associate course with AWS, those are some of the things that you'll be doing. But again, also for you, all the questions that are being asked here, I will compile the answers and then I'll just share them as one file for the benefit of all of you. I like those questions. Those questions are good. It shows people who are engaging with the content, and that's very good. So back to our CIDR ranges. So we have seen that, and now we are talking about these IPs. In the morning when we are talking about IPs, you remember that it was mentioned, I believe Joy mentioned, that it was either today or we mentioned it yesterday when we were covering the other content, that there are two types of IP addresses. We have public IPs and private IPs. Public IPs and private IPs. And because Your VPC is supposed to be yours. It does not belong to any other person, does not belong to your competitor. Therefore, the IP range that you're going to give it, initially, it is actually going to be private. Yeah, they are going to be private IP ranges. And some recommendations have been made, and you'll see those recommendations in a soon to come slide. But here we say private IP ranges should be used according to RFC 1918. RFC 1918, and I think I had done research on what that one means in full. Let me just redo it because I must have closed that. RFC, or someone that has come across it. Do you know what RFC 1918 means? It is something that some people did. You know, these standards are things that were set by some groups. Yes, so RFC 1918 in full is Request for Comments document, which was published in 1918 by, no, it was not published in 1918, sorry. So 1918 is the number of the standard that was actually published in a document called Request for Comments, and it was published by an organization called Internet Engineering Task Force, Internet Engineering Task Force, IETF. And this defines private IPv4 address ranges. So you will discover, even as we continue, that there are different bodies that are tasked with defining the ranges that we are going to use. Like, for example, what we are seeing here about the IETF, they are the ones that define private IPv4 address ranges. And these ranges are not routable. They are not routable to the public internet. They are meant for use within private networks. So these private networks can either be your home office, they can either be in your homes, in your office, or in the cloud VPC. In the cloud VPC, you see, cloud VPC has been used as an example there. You know, it has been used as an example there. So that's what you will see. And by default, in most cases, what I have seen is that when we are creating VPC, we like using 10.0.0.0/16, which gives us a total of 65,536 addresses. You know, it gives us this many addresses. However, we are not going to use all of them. We are just starting with a big pool of addresses so that when we start doing our subnets, let's say we have many subnets, we have like 20, 50, 100, or in circumstances, we push to the maximum of 200 subnets. We want to make sure that these subnets are able to get their own slice within this range. And by slice, I mean the resources within the VPC should not have IP addresses that clash. Each resource in a VPC, and this is important, and this is actually an exam question. Resources in your VPC should not have similar IP. Because so you know the work of an IP address. An IP address, what is the work of an IP address? Someone remind us, because it was taught to you. What is the work of an IP address? Because by understanding what an IP address does, then you will know why it should not, why two resources should not share the same IP address at the same time. What is the use of an IP address? People. Thank you, Rich. It identifies devices on a network, uniquely identifies devices on a network, uniquely identifies devices in a network, identifies and locates devices. Very good answers. Awesome, awesome, awesome. But up and above identifying these devices, it also does another thing. So it identifies who the device is. You know, that's addressing, number one, and where it is located, so that data can be sent and received correctly. You know, so that data can be sent and received correctly. Very nice. It is like a phone number of a computer. Very good, Amy. Very good, Amy. So that is very, very good. Thank you, everybody who engaged in that question. So that's why we are saying your resources should not have the same IP address. No. Again, using a simple example like the one that Amy has given us. Imagine me having the same phone number as Dan, and then Amy, you're trying to call Dan, and then now you get me. It does not even make, it does not make. So we should be having different phone numbers to start with at the same time. Maybe we might even define the last digit. Maybe we have all the other, it's normally 10 digits if you start with 007 something, 10 digits. Maybe the first 9 digits can be the same, but the last one can be different. That's why sometimes you even get wrong numbers. Someone fingered 1 digit wrong, and then you get a wrong number. Or if you are on the luck side of things, is it really lucky? Okay, not really lucky, because you'll have to reverse it anyway. You're on that receiving end. Someone sends money to a wrong phone number because they clicked maybe a digit or 2 wrong. So that kind of uniqueness is important for VPCs. So VPCs should have, VPCs and its components should all have different IP addresses, but within the range that has been defined. Now, within the range that has been defined. Within the range that has been defined. So the private IP ranges should be used according to RFC 1918. That is
Hello,
important.
Patrick.
Yes.
I have a question.
Yes, please.
You have said that VPC uses a private IP address, but again, you said that in order to access the internet, you use a public IP address, and I can see a VPC uses a gateway to access the internet. So how does that work?
Good question. Very, very good question. Very good question. Who was that? Who was that? Sorry, I did not see you.
It's Clinton.
Clinton. Thank you very much. Thank you very much. So what we say, and you will see it. Well, I hope time will allow us to do the demo, but you'll see it because you are still far behind in the content, but you'll see it. Now, there are actually two. Thank you, Ben, for answering it there, Musembi. There are actually 2 IP addresses that are given to most of the resources you will find in AWS, including the VPC and its components. So one of those is what we call the private IP address. So the private IP address, we are using it for internal communication. You see, the same way in an organization, you will have your own private IP addresses, or even in your home network, you'll have your own private IP address that maybe allows your computer to communicate with your printer. These two are communicating locally without going to the internet. That is private. Now, public IP, because VPC still have that for you to be able to communicate, or rather the components within the VPC, like let's say EC2 instances. If you go deep down, Pale, you get your EC2 instances. And when you were creating those EC2 instances, what did you discover? You discover that there are actually 2 IPs. And I know you guys were not paying attention to the private IP address because you were focusing with using the public one, which will now allow us to SSH, which will allow us to SSH. So that is very, very, very important. Clinton, umesahau Joy's story of a guy who configured a public IP open instead of private. Cost went up from 30 to 60 per hour. And by the way, it's very serious. And I actually like that story. It just shows you that you need to be very attentive when you are doing these things in the cloud. Otherwise, you will really, really cause your organization's problem, or even yourself. So what I can add to what Musebi has said is that when you create VPC, you first of all have to assign it the IP the way we've said, and that the IP that you are assigning it is going to be a private IP that is in the range. And those ranges, you are going to talk about them, and you'll see like one of them is 10.0.0 /16. Another one is 172.16.0.0/16. And then we have yet another one, the famous 192.168.0.0/16. No, that's why when people are being asked, what is your IP? Most people were giving their private IPs. you know, guys that were giving their 192.this.this. But if you run ipconfig, you will find, especially let's say someone like me who is connected to my router or to the internet through an ISP, I have two IPs. My Wi-Fi adapter shows that I have a 10. No, I have yeah. What was the just a second? This is same as a Java. Let me do a CMD run as admin. ipconfig. So you see, I have the 172 here. You see 172.18.160.1, and then that is connection specific to DNS suffix. But what I wanted to pay attention to was this one, wireless LAN adapter for Wi-Fi. I have 192.168. You see what we are talking about, the private 192.168.100. You see 192.168.100. However, there is that time, and you've done a lot of things in this world. There is this site that you can also do, what is my IP? And there are so many people who know why we use this, especially if you're using DNS, or no, not DNS, when you're using a proxy, or you are trying to hide behind something, or you want to access things that you let me leave it at that. I don't want to go past that because I might give people some ideas which are not very, very advanced stuff. Okay, so let's see. You see, like here, I have 102.213.49.18. You see that? You see that? So there is this, and then there is that my CMD, or rather, when I ran ipconfig, I got. You see those two. They are different in that sense. So I'd like to assume rather that this is my public IP address, and this here is my private IP address. Why is this one private? Why is this 172 point this? Where is it? Not 172, 192.168 private. It is private because you've been told that we have ranges that are into that same area of 192.168 being categorized by RFC. They are the ones that are saying, yani in Swahili Frank, we say, how ndio kusema. So they are the ones that say, so they are the ones that defined and said 10.172. And 192. Those ones are for private IP ranges. And again, now you've also seen an example of a public one. When I ran what is my IP, you get something like that. So when you're connecting to a proxy, and then you want to check if that proxy, if that what was the name of those things? What were we calling them? It's example since I used it. The likes of a tunnel bear. So those things that actually gives you, is it a VPN or a VPN? Yeah, a VPN. Yeah. So those VPNs that actually give you access, you pay for it. It can give you access maybe even to a network that now reads that you are in the US, for example. Now, when you are connected to your VPN and you run what is my IP, it will read that and show you that now, instead of you being where I am currently, which is telling me that I'm in Nairobi, which is a lie. I'm actually outside at the outskirts of Nairobi, but maybe my area is not really red. So, but that will show you that you are actually in the United States of America, man, when you are still here, when you are still here in Banana, in Banana. So that is that. So that was good. Back to our notes. I hope you guys are learning. I hope you guys are getting. This is very, very important. And I don't mind repeating, but this is very important. So we are saying that the private IP addresses are defined by the RFC 1918, and you have read and seen what RFC 1918 do and which body is tasked with that work of defining private IP addresses, where we say that falls under the responsibility of IE, what was it? It was IEFTS or what? Let me just scroll back to my notes a second. So nobody heard me say it. Someone should have typed it so that we continue. Where is that body? Okay, you'll get them in the notes, but there's actually a specific body that is tasked with doing that. They're the ones that define and say that these are the ranges that you're going to use. So I'll not belabor that. we can move on. So private IP address ranges. We talked about these ones in the morning about the IP ranges, and you guys also had an opportunity to try and play out with some of them. So if you're given a number, then you're told that maybe convert it to zeros and ones. You are able to do it, and you did it very well. So here we are seeing that when Amazon VPC is created, you choose from a CIDR block for the following IPv4 addresses ranges, which are specified by RFC 1918. So you see like 10.0.0.0 the range from 10.0.0.0 to 10.255.255.255. An example there might be our VPC CIDR block, which you said maybe it can take something like 10.0.0.0/16. Then in the next range, which we have 172.16.0.0 all the way to 172.31.255.255. This one, you have an example again in the VPC, because this is also private. You can have it like 172.31.0.0 again /16. And then for the range between 192.168.0.0 all the way to 192.268.255.255, you can have an example again for our VPC, maybe at 192.168.0.0/16. And we talked about the slash, where I was saying if you see a small slash like /16, that is the largest because it has many addresses, 65,000. Then when you see a /28, that is the smallest. That is the smallest. So the allowable block, there is an allowable block that you have been given, or rather allowable range of slashes you are allowed to use between /28 to /16. Anything that falls in between there is what you can use when you are trying to provision your VPC. And we say a public routable CIDR block that falls outside the private range can be used. A publicly routable CIDR block that falls outside the private range can be used. But there's a however. However, it is not recommended. It can be used, but it is not recommended. This situation can cause issues if you are using publicly routable resources. If you're using publicly routable resources to the internet. So you have resources that you really don't want to expose to the internet, but the CIDR block that you've used gives it that permission to access. It gives your VPC the permission to access, because remember, the routing that you're defining it through the IP. If you give it an IP that falls outside the range that has been recommended for you, then you stand that risk of exposing what is supposed to be private to public. You understand? You are exposing what is supposed to be private to the public, and you guys, you wouldn't even start to imagine the consequences of that. And good news here is that you don't really need to cram all these things that I'm talking about when it comes to CIDR block ranges, CIDR block notation, or even how to assign. You don't need to do that. There are calculators that you can use. There are calculators that exist online that you can use, and one of them is called the subnet calculator, and another one is called the CIDR calculator. And I went ahead of you, ahead of time, and I already opened a link, and we are going to look at it in a second. But let us just look at this, for example, first. Within each subnet CIDR block, AWS reserves first 4 IP addresses and the last IP address. Joy mentioned this. So, like we have 10.0.0.0. So in the 10.0.0 range, the first address, second, third, and fourth, and the last one, they are normally reserved, regardless of the number that you're using. Even if you're using 192 dot whatever, or 172 dot, the first and the last, the first 4 and the last one, they are normally reserved. The first is for network address. The second one is for VPC router. The third one, which is a .2, is a domain name system server used by AWS. And then a .3 is reserved for future use. So AWS is futuristic, and maybe they feel that they might want to use that one, and they don't want to start telling you guys, don't use this, we are now using it. So they have kept that one for their own use. And then we have a .255, which is the last one. Remember, it starts from .0 to .255. So at .255, we have network broadcast, but this is not supported in the VPC, but it is still reserved. regardless, it is still what? It is still reserved. So just note that the first four and the last one, and the last one IP address, they are normally reserved for use by AWS. I don't know about the other clouds, but this is what you know about AWS. And it's important for you to know that because of exams. Now to the calculator. This is our calculator. This is our calculator, the subnet calculator. And all you need to do, you just need to enter here. You just need to enter here the side range that you've decided to use, or rather the IP that you've decided to give. You've decided to give your VPC. Once you enter it there, like for example, I entered 10.0.0.0/16 and I clicked on calculate. It gives me many things here, some of them that are not that important to me, but the most important thing that you see here, sorry, the most important thing that you see here, it actually shows you your subnet mask. And you see you have your subnet mask. Those guys who have gone through CCNA will do CCNA. So you can actually have a subnet mask, but of importance, it gives you the number. You know, you first of all calculate before you start provisioning. It gives you the number of IP addresses that you can access. You know, it first of all gives you the number of IP addresses that you can access. So this is 65,536, which is a big number. And you'll discover that when we are talking about subnets, we will not actually be focusing on we will not be using /16. We'll use a larger slash so that we get fewer addresses, because again, we don't have use for 65,000 IP addresses. Come on, that's a lot. You know, that's a lot by a mile. That's a lot by a mile. That's a lot. So another thing that you see here, you see the full CIDR block notation, the same one that you've entered there. You see the range. It tells you it ranges from 10.0.0.0 all the way to 10.0.255.255. You see, so it shows you all of that. These are the important bits. Leave this other advanced stuff that is not important. So Rich is asking, which criteria does Amazon VPC use for neighbor discovery? Which criteria does Amazon VPC use for neighbor discovery? What do you mean by neighbor discovery? I've heard that term before. Oh, okay. So I'm seeing that neighbor discovery is about how devices learn about other devices on the same network. How devices learn about other devices. Well, this is advanced networking stuff. Reach the network engineer. Okay. So they are saying that IPv4 uses ARP, address resolution protocol, and IPv6 uses NDP, neighbor discovery protocol. So the question becomes, does AWS VPC use ARP or NDP, like blah, blah, blah? Let me see. So, you know, by default, logical isolation is needed. Logical isolation is needed. Is needed. So, what Musembi is telling us here is that Amazon VPC does not use ARP or traditional neighbor discovery protocols like NDP between instances. Instead, the VPC control panel handles neighbor discovery implicitly through its software defined network SDN using managed mapping between private IP address and virtual network interface VNI. So I will skip this question and just say that this is advanced networking, which falls outside this. I don't really make head and tail of this, but it's a good question nonetheless. So maybe if interested, you can engage with what Nania has written there, with what Musembi has written there. But for this course, this is outside the scope. It's outside the scope, but it is still a good question. It's still a good question. It's a good question. And actually, for those who are interested with going deep on networking, there's actually a specialty certification in AWS called AWS Networking Specialty. Yeah, it's just the same. AWS networking specialty, where you now go deep. You go deep into networking and you become a pro, an expert in networking. So that is that. Now, this is the calculator that I was showing you and I've just shown you, and I hope that one makes sense. I'm looking at time and we are not doing very well on time. Let's just continue. So the VPC components. So when you're talking about the VPC component, we've already said that a VPC is a virtual network that you define and it resembles a traditional network in a data center. Important concepts here is like what we've just been talking about for the past 30 minutes. CIDR block, a private range should be given a range between /16 and /28. That is the allowable range. And then subnets allocate a range of IP addresses within your VPC. And then we have a route table. Someone asked about a route table. So a route table has rules, which are also known as routes, that VPC uses to route traffic. So it tells you the barabara that the traffic is supposed to follow, or the road or the way that the traffic is supposed to follow. Then we have internet gateway, which attaches to your VPC, as you saw in that diagram, and permits communication from your VPC to the internet. And then now we have this concept about VPC endpoint, and I want you to pay attention here that a VPC endpoint is a private connection between your AWS services without the need of the internet. So it's possible for you to have services when you're provisioning services, or rather when you're configuring services or even drawing an architecture diagram. It is possible to have services. Oh, okay. Hey, Joy, you've caught me there. Hey, say kwanikwa. But that's very, very interesting. Now, remember, when you're talking about VPC endpoint, sometimes you might need a service to connect to what is in your VPC. When you're provisioning your VPC, there are those services that will be inside your VPC, and there are those services that will be outside your VPC. Like, for instance, something like your S3 bucket. Ordinarily, we have our S3 buckets outside the VPC, and it might need to communicate maybe to an instance that is inside the VPC. And then you're asked, how will these two communicate? What is the safe way of these two communicating? And the easiest way to do that is using what we call a VPC endpoint. And we'll be talking about VPC endpoints at some point, but not today. But that is just something that I needed to mention there. Then, common ways to access Amazon VPC, we have the AWS Management Console and the AWS Command Line Interface, or the CLI. And also, again, in the process of time, we will bring you to the CLI so that you guys get to see how a CLI looks like. Now, what is Amazon VPC? That one we have discussed. What are CIDR blocks? That one we've discussed. So these notes are yours to engage with, because it's just a repeat of what we have discussed up there. Up there. You guys have made me so cautious about using Swahili, because now we know Frank is with us. Yeah, but Frank will teach you Swahili. You will learn a few words here and there, like sasa, jambo, hakuna matata. No, hakuna matata for the tourists from Europe. But yes, there's no problem. Hakuna matata. So we continue. Question. I have a question. And be honest. If you feel that it is a marathon, this session is a marathon, please react in any way that you find. Any way you can throw a thumbs up, you can laugh, you can cry, anything. I'm trying to give you guys a minute to breathe in and breathe out. Is the session a marathon? Are you finding it a marathon, or are you understanding? Woy Elfas, woy, Kai. Of all the reactions, you just decided to give us an emoji showing that you are crying or something. 10 minutes is such a long time. I don't want to keep you guys for long. That will take us past time. Nobody else is reacting. Purity, you're finding it cool, yeah? Awesome. I can see you. Okay. Frank, Amy is asking, which country are you from? If you're comfortable sharing, where are you from? You're from Ghana. Nice. Ghana. I have a very good friend and colleague from Ghana. Ghana is such a beautiful country in Africa. You come from Wodemaya's country. That is awesome. Ivy, why are you laughing? I hope it's in relation to the content. And Frank. Okay, awesome, awesome, awesome. So guys, I just want to request that we just be a bit patient. It's not Chocha, it's not Chocha. It's true. I actually have a colleague from there. I have a colleague from there, and he will be coming to Kenya. We'll be attending an AWS event in Meru sometime in November, and you guys are invited. I'll share more details as the day progresses. It's a community day for students. So we'll be going there. So yeah, he's coming all the way from Ghana. Ghana is such a nice country. Amazon VPC. And I like their drive. Together with our Nigerian friends, I like their drive for technology. You know, they are so passionate. There are so many good engineers there. That's very good. Our regards to your friends in Ghana. Tell them that we send our greetings. Kenya, we like sending greetings. Yani tunapenda kutuma salamu. We like sending greetings. So, guys, I promise, I really want us to finish this. I've known Wodemaya through YouTube. I like him because he's encouraging people to be doing things African, to come back to Africa and develop Africa, to develop the motherland, you know, develop the motherland. We have our own challenges, yes, that is true, but it's always good to develop our motherland. So Amazon VPC components, and we've been talking about this. That's why I feel that we are able actually to finish this quite in a few. So when you're talking about VPC components, of course, the first one is the Amazon VPC itself. You've seen what the internet gateway does, allowing access to the internet, giving VPC access to the internet. Then we have NAT gateway, which we'll discuss in brief. Then we have route table. We have public and private subnets, which we've talked about. We have security groups, and we have network access control list, or NACLs. So Amazon VPC components are used to configure networking in a VPC. Let me consult something. Let me consult something. Take this time to stretch, but don't go anywhere. I'm just consulting. Sorry, guys. I'm also taking a cup of water. Okay, as I'm waiting for. Okay, cool. Cool. So we are trying to look at this Amazon VPC components, and give it a second. Okay, considering that, two things will happen. One, we need to talk about these components, and then we also need to we also need to talk about we also need to do a demo on the same. And this being a very important topic, very important topic, because it's your gateway into the cloud, and this is the first service, I am going to recommend / propose that we end it here and pick it from here on Monday. So that you guys can at least, first of all, get time to breathe and just appreciate that now we are entering the cloud, so that on Monday morning when we come, I will pick up from here, and then we will also be able to do the demo. Because again, our interest and what we have always said together with Joy is that we don't just want to finish the content we have, or we don't want to finish the syllabus. We also want you people to understand, because now when you're talking about AWS services, these are things that will come in your exams. So we want you people to understand, you know, and because you have access to these notes in your own accounts, that you knew I was smart. It is a shared responsibility. It's a shared responsibility. Both Joy and myself are smart. That's why you have said you are smart. For two, R is for two. Together with the Langley admins, we are all smart because we really care about people and we want you people to understand what we are teaching. So I was saying that if possible, please try and interact with these notes. Just try familiarize with them, gain skills. Yes, Musembi, you are right. It's not even just about the exams. It's also about gaining skills and being able to perform on the job, being able to perform on the job. So you pass your certification because the certifications are supposed to certify that you can do what the certificate says you can do. Kuliko, you get yourself that you are 8 times certified when you cannot actually provision and secure an EC2 instance. That is so regrettable. And we've seen so many such cases. So it's important that you people learn. And I'm advising you that next week when we come, please find ways of catching up with your labs because things are getting a bit heated. Find ways of getting through with your labs. And then finally, I also say, try and come and join the next meeting with your machines, because when I'll be doing the demos, it will become even better if you guys can be learning and doing at the same time as we are demonstrating, because in IT we learn by doing. So yes, so thank you so much for your time. That was awesome. And so
Hello.
yes, Mark.
There was an announcement you are supposed to make. Please don't forget.
Yes, thank you, Mark. Thank you, Mark. Whoever wrote there that they knew that I was smart, Apokwa are smart, also add Mark there, and the rest of you. Yeah, you see, he has reminded me. He has reminded me that there was an announcement. And then there are 2 pieces of announcement. Announcement 1, if you are from channel /54, if you are from Kenai 54, don't leave the meeting when 53 are leaving the meeting. In fact, just a second. Thank you, Mark, for that. That was awesome. Just give me a second. I want to grab a link and give to 53. 53, I want you to join that meeting immediately so that I communicate what I want to communicate, and then you guys can do what needs to be done, and then people can now do what? People can start their weekend. Learning Members Day. New meeting. Start an instant meeting. Let me get the link I give you. So if you are from 54, then you remain here. If you are from 54, you'll remain here when the others are leaving.
Stop recording, Patrick.
Oh, stop recording. Awesome. I had forgotten. Thank you, Esther. Have I stopped? That is stopped sharing. One sec. Oh. Now what's happening? These things are interesting. Okay, stop recording. My comp has hanged kidogo. Give it a sec.